Welcome to the CXO Talks, an extension of our newsletter named the CXO Journal, and brought to you by getaconnectglobal.com. In this edition of the CXO Talks, let's learn the art of estimation for CXOs. CXOs are supposed to take decisions. Decision-making is not easy, mainly because in most cases there is very little or no actual data available. So how to take decisions? The art of estimation comes to help here. It was, in a way, invented by physicist Enrico Fermi, who was known for his ability to make good approximate calculations with little or no actual data. They are usually back-of-the-envelope calculations. What is the market size of solar panels in India? How much budget should you plan for your company's new digital marketing? How much should you bid for a new project with a blue-chip client? By when can you finish that project? How much plywood would you need if you want to furnish your house? How much money do you need for your retirement? These are the real-life problems we never solved during our school. We are taught to solve problems in schools, but that was very superficial. It was just a math problem for us. We are used to get a ready-made question with ready-made data, numbers, and we simply do the math and arrive at an answer. This is nothing but a calculation, not the problem solving. In real life, you need to convert the problem into numbers, solve it, and again convert that answer from numeric form to real-life solution. That is nothing but the art of estimation. Estimation is part of everyday experience, be it the time to reach office, quotation to customer for a specific project, and so on. Most of the times we never know all the facts up front. There are always many variables interacting with each other, making things really complicated. Estimation provides you with a simple but a powerful solution. As an answer to the complexity, it gives you that simple ballpark number, makes you look at the power of range, saves time, helps take decisions faster, and gives a reasonable confidence to go ahead. Let's learn to estimate anything in a very simple way in this edition using Fermi's method of estimation. What is estimation? Estimation, or estimating, is the process of finding an estimate or approximation or a guesstimate, which is a value that is usable for some purpose even if input data may be incomplete, uncertain, or unstable. How to estimate anything? Let's now understand the Fermi's estimation process. But before we do that, let's first come on the same page for the following basic assumption. The power of 10. While estimating, never consider the precise numbers, because everything is an estimate. Any numbers to be considered for calculation and estimation should be taken using the power of 10. For example, in power of 10 way, we express numbers as a digit between 1 to 10x some power of 10. For example, if you want to express 135 and 459 in power of 10, express 135 is equal to 1.35x 10 squared. Express 459 is equal to 4.59x 10 squared. This is telling us that both belong to the same power of 10. Power of 10s are 10 to the power of -2, 10 to the power of -1, 10 to the power of 0, 10 to the power of 1, 10 squared, 10 cubed, and so on. This is nothing but 1/100, 1/10, 1, 10, 100, 1000, and so on. Benefits of the power of 10. 1. To find out how big the number is. For example, 1.35 times 10 squared tells us that this number has order of magnitude of 100. But, say 7.95 times 10 to the power of 6 tells us that this number has an order of magnitude of 1,000,000. Hence later one is much bigger. 2. Comparing numbers. For example, 2.4 times 10 to the power of 6 and 6 times 10 to the power of 6 belong to the same power of 10. They are kind of similar. 3. Easy calculations. While estimating, there is no need to calculate precisely. The goal is to do the back-of-the-envelope calculations and take decisions faster. If you use power of 10s, calculations become easier. The estimation process. Now with the basics out of the way, let's understand this very simple but very powerful Fermi's estimation process. Let's understand it with a simple example. Our goal is to find out the number of people who are currently using eyeglasses in the world. 1. Find assumptions or factors. The approach here will be to find out total world population currently and multiply that by the percent of population who are using or need to use eyeglasses as of now. We know a ballpark number for world population, which is 7 billion equals 7 times 10 to the power of 9. We need to now find out how much percent of this population actually need eyeglasses. 2. Underestimate and overestimate. It is very subjective to actually find out the precise percentage here. In order to make this work simpler, Fermi suggested to first find out two extreme cases. One is to underestimate and then overestimate. This will reduce any bias you might have related to the case in point. In the example of eyeglasses, underestimate. This can be, say 1 in 10 persons is using eyeglasses. This is nothing but 10% of the people wear and need eyeglasses. Overestimate. This can be, 1 in 1 person is using eyeglasses. This is nothing but 100% of the people, each and every person, wear and need eyeglasses. So the underestimate is 10% and overestimate is 100%. 3. Take geometric mean of the above. Geometric mean of numbers x and y equals square root of x into y. Once you are ready with underestimate and overestimate as mentioned in the step above, you should then find some midway number as an estimate. Intuitively, we tend to take an average number in such case. But if the range is too large, average doesn't actually represent the right number. For example, average of 1 in 1 million equals 5 lakh. But this number does not represent 1, underestimate, and is actually biased towards 1 million. To counter this, Fermi suggested to take the geometric mean of the two numbers. For example, geometric mean of 1 in 1 million equals square root of 1 times 10 to the power of 6 equals 1,000. In the example of eyeglasses, the geometric mean of two percentages 10 and 100 equals square root of 1,000 equals 31.62%, equals approximately 30% of the people need eyeglasses. 4. Take that number for calculations, do rounding off. This is nothing but the simple math. This is what we have been doing in school and all these years. In the example of eyeglasses, 30% of 7 billion equals 2.1 billion equals approximately 2 billion people need eyeglasses. 5. Interpret and compare with known quantities. I simply Googled this, number of people wearing spectacles, and found out that 4 billion is the answer. According to our calculations, 2 times 10 to the power of 9 and 4 times 10 to the power of 9 are nothing but the same numbers considering the power of 10, aka the order of magnitude. Hence, this estimation is good to go. In some cases, simply looking at the final estimated number doesn't convey anything to the users. For example, if I find out that 120k liters of water is needed by my society from outside tankers every day, that doesn't tell me anything. But if I come to know that we need 6,000 buckets of additional water, which actually means around 20 buckets per flat per day, is a number which moves me. Hence, once you find the estimated number, your job as a CXO is to convert that number in some interesting comparable examples. Once you communicate that example to your audience, your message will be received properly by them. This is nothing but convert the problem into numbers, solve it, and again convert that answer from numeric form to real-life solution. 6. Refine each step. Of course, this is the last step, but it should close the loop. Question assumptions, which can be changed, which answers might be changed, compare estimates from other team members and question why it is different. Estimation is often the process of converting the complexity to simplicity. It should be so simple that it appears like the back of the envelope calculations. To summarize, find the right assumptions, convert them to numbers by using the underestimate and overestimate technique, reduce the bias using the geometric mean, use simple math and the power of 10 to calculate, round them off wherever needed, interpret the solution and compare with known real-life examples, and finally refine each assumption to fine-tune the estimations. We are calling this as an art. Yes, it is nothing but an art. Estimation is an art. It should be your back of the envelope calculations. It should never be the bottleneck. It should lead to faster decision-making. Hence, learn the art of estimation and be a smart CXO. I hope this is helpful. Please do share your experiences and comments to make this discussion richer and let everyone learn more from the same. Thanks for watching. Do subscribe to the channel. Let's connect in the next video with few more insights to manage and scale up your business systematically.